Okay, I want to have a look at part C of that question about the earthquakes in California. And we're asked up here, what's the probability a randomly selected earthquake has a magnitude that falls between 5.8 and 7.1? So mathematically, I would write that as probability or proportion, if that's the way you want to look at it, that x will be less than or equal to 7.1, but greater than or equal to 5.8. Yes, I said greater than, and I know this thing says less than, but if you remember, I don't know, grade 9 or grade 10 mathematics, when you're dealing with inequalities and you write the inequality on the left-hand side of the variable, it actually means the opposite of what it appears. Anyway, the whole upshot of it is, I want to know what's the probability x will fall between a low value of 5.8 and a high value of 7.1. All right, I draw my normal curve. Here it is. I know the center is at 6.2. I want to go between 5.8, which lies below 6.2, up to 7.1, which lies above. And I want this area in between. And again, if I was doing this by hand, I would work out the z-scores. And this time I work out two z-scores because there's two x values that I'm interested in. So the lower x value, 5.8, gets standardized or has a z-score of negative 0.80. I should be using two places after the decimal, but I think this works out anyway. Just give me 0.80. And 7.1 corresponds to a z-score of 1.80. Again, I should be using two. All right, so I redraw my distribution, this time from the perspective of the standard normal distribution where I'm talking about z-scores. Here's the center at 0. I want to go between a negative 0.8 and a positive 1.8. So the way we work this, and I've got it written mathematically down here, find a probability x lies between these two values is the same as finding the probability or the area that z will lie between negative 0.8 and 1.8. And the way we work this out using tables, keep in mind tables only give us areas to the left. When I'm looking for area between two values, I always start with the highest one. Right here, my z-score is 1.8. I'm going to go into my table in a second. I'm going to look for the area that lies to the left of a z-score of 1.8, and that's going to be everything that lies from the left of 1.8, and my table is going to tell me that value is 9641. Okay, but I don't want all of that area. I want some of it, but not all of it. What I want to do is figure out how much area lies to the left of this z-score of negative 0.8. I look that up in my table. I get 0.2119. And what's going to happen is I'm going to subtract this area here in this tail I don't want. I take the big area, I subtract the smaller area from it, which is what I've done right here. And what is left over is the area that I want. So I get the 7522. All right, so let's go to the table in our course notes and have a look. I'm looking for a z-score of 1.8, and here I've got part of our table. Let's see. Here's 1.8, and whoops, 1.8 is there, and 1.80, yeah, hang on now, is right there. There's my 9641, so all the area to the left of 1.80 is 9641. And if I scroll down and I look at the areas to the left of a negative z, the other z-score I had to look up was negative 0.8. There it is. And if I go over to the second 0, then that area is the 0.2119. Okay, so that's where those numbers are coming from in this problem right here. And of course, I could go to my trusty Minitab. Okay, so coming in the Minitab, again, I'd go to the Graph tab, Probability Distribution Plot, view the probability. Of course, with this one, I don't have to bother doing z-scores. I just look at it from the point of view of the population I'm looking at, which is earthquakes in California. I give it the mean and the standard deviation. And this time, I'm going to give it a couple of X values, so make sure you change the radio button. And I want the area between two X values. And by the way, as soon as I choose middle, notice how a separate X value box opened up down here. And we want it to go between 5.8 on the Richter scale to 7.1. I click OK, and here's the answer I get out of Minitab, 0.7522, which corresponds with what I would get if I was using tables. Okay, I'm going to generate maybe another video, possibly one more, to illustrate some other parts of this problem.